very much, madam. Introducing. Can I share my screen, madam?
Yes, sir.
It is visible, madam. My screen visible, madam.
Not it, sir.
No, madam.
No, sir.
Sir. No, sir. Screen, no. No, madam.
Yes, sir.
Okay, thank you. Good morning, one and all. Inviting me for 6 days FDP on GAN based hybrid deep learning approach to IoT. Myself, Dr. Bhajan Sheikh. I am professor and Institutional Innovation Council President in Ramchandra College of Engineering, Yellow. And also, I am happy to hear to elaborate on the title on GAN-based hybrid deep learning approach for IoT. It will be very much interesting in the new knowledge and new data. It will helpful for gaining fundamentals and basics in technology and also future applications. For gaining new knowledge, it will helpful for writing articles, writing emerging technology research proposals, and also teaching in different ICT tools for the students also. I will explain clearly on this lecture GAN-based hybrid deep learning approaches for IoT. I will say that generative adversarial networks. It have emerged as a powerful tool and also in the field of deep learning, enabling the generation of realistic synthetic data. When we are discussing this topic, you have to understand the approaches and how the combination with other deep learning techniques like generative adversarial networks offer a robust approach to address various challenges in IoT. First of all, we have to understand what is GAN, basic concept. Generative adversarial networks consist of two neural networks, a generator and discriminator. The generator creates a synthetic data, while the discriminator evaluates its authenticity. This adversarial process drives both networks to improve, resulting in high-quality synthetic data. And when we are discussing about hybrid deep learning is this approach combines multiple deep learning techniques such as convolutional neural networks, recurrent neural networks that will be called as RNN, and GAN to create powerful models for complex tasks. We will see detailed what are the keyways, techniques, and also we will see related to like introduction, overview, disadvantages, and how The proposed approach will be used for real applications, key components, hybrid model using IoT data, advantages, case studies, experimental results, and discussions, and also case studies and future research directions. You will see a detailed explanation on this topic. You can understand clear picture and clear knowledge for implementation of real world and real applications. First of all, when we are uh, explaining about the introduction to IoT and its challenges, here we have to understand the rise of the Internet of Things like as a revolution our world by connecting billions of devices from smart home appliances to industrial sensors, generating vast amounts of data. And coming to challenges of IoT, it takes the major role today's technology like industrial 4.0 and also now 4.0. And also the challenges, however, IoT data poses unique challenges for traditional deep learning methods such as handling, heterogeneity, scalability, and real-time processing. When we are discussing about challenges of IoT, when there is a challenges, there we have to see the security level also related to IoT security. IoT security, when we are discussing related to IoT security, it is a adversarial attacks and intrusion detection. Adversarial attacks is a GAN can be used to generate adversarial examples to test the robustness of IoT security systems and identify the vulnerabilities. And also coming to intrusion detection, this by analyzing network traffic patterns, GANs can detect anomalies and potential security breaches. And this is the overview of the deep learning and the generative of the adversarial networks. We will see the comparison and differences between the deep learning and the GAN. You can understand the clear picture and clear description. When we are discussing about deep learning excels at extracting complex patterns from data and also making it suitable for IoT applications like anomaly detection and predictive maintenance. And coming to generative adversarial networks, it consisting of a generator and discriminator, what we have discussed in the previous also detailed this concept. And also it is a powerful tool for generating synthetic data when it can be used to augment or improving existing data sets. And coming to disadvantages or limitations of traditional deep learning approaches for IoT, you can major techniques you have to understand the how the disadvantages and what is the basic concept world. And here there are data heterogeneity, that is IoT data often comes from diverse sources, make it challenging to build a single model that effectively analyzes all data types. And coming to scalability challenges, the sheer volume and velocity of IoT data requires scalable models that can handle large data sets without compromising performance. And coming to real-time processing, many IoT applications required real-time analysis with traditional deep learning models often struggling to achieve due to their computational complexity. That is the main disadvantages traditional deep learning approaches for the IoT. Traditional takes a major role major importance in this. And also here, how the proposed hybrid deep learning approach and what are the different conditions for approaching hybrid deep learning is very important. Here, we have to understand the purpose and solution involves combining the strengths of deep learning and GANs to create a powerful hybrid architecture for IoT data analysis. This hybrid model takes place the leverages of the pattern recognition capabilities of deep learning, with addressing the challenges of the data heterogeneity and scalability through synthetic data generated with GANs. Here, when we are discussing like hybrid deep learning approaches, here hybrid deep learning models for IoT, it is a combining of GANs with other deep learning techniques like CNN and RNN. Already we have discussed that CNN is a convolutional neural networks and RNN is recurrent neural networks. And here, what are the benefits of hybrid deep learning approaches models for IoT? Benefits for hybrid models for IoT applications. And IoT security applications like anomaly detection and intrusion detection using GNS for generating synthetic data for enhancing security models. And also here the key components of the GAN-based hybrid model. GAN hybrid models, there are the different components involving in this sensor data augmentation, and deep learning model. When we are discussing about the sensor data is the model utilizes the real-time data from various IoT sensors, capturing information about temperature, pressure, motion, and more. And coming to another component is a data augmentation. It is a GAN component generates synthetic data to enhance the training data set, addressing the issues of data heterogeneity and sparsity. And coming to another hybrid model is a deep learning model. A deep learning model is a process of the real and the synthetic data to learn complex patterns and extract meaningful insights. When we are discussing the components or hybrid or anything, there are many real-world applications related to like smart cities, healthcare, industrial IoT, and also autonomous vehicles. Generally, when we are discussing about the real-world applications related to smart cities, there is a traffic management, predictive maintenance, and energy optimization. This is the application. And coming to healthcare related, it is the medical image analysis, drug discovery, and also personalizing medicine. And coming to industrial IoT, it takes a major role. It is industrial 5.0 nowadays. Robotics advanced related to IoT also. It is the industrial IoT takes the major role for the quality control, predictive maintenance, and also supply chain optimization. And coming to another real-world applications, now the society is related to autonomous vehicles like data augmentation, object detection, and decision making. And coming to how the training and how the related to the training of the hybrid model will be made useful. You can observe the clear picture of the hybrid learning related to how the improvement and what are the key measures used for the training is very, very important. When we are discussing that the data collection and also, and here when we are discussing about data collection, here the real-time data from various IoT sensors is collected and pre-processed to achieve consistent format and quality. And coming to another, when we are discussing about the synthetic data, the synthetic data generation is the GAN components generate synthetic data based on the real data capturing the underlying distributions and patterns. And coming to related to training of the hybrid model using IoT data, the model training, that is the deep learning model, is trained using a combined data set of real and synthetic data leading to improved accuracy and generalization. These are the three techniques used for training of the hybrid model using IoT data. And coming to advantages of the hybrid approach over standalone for deep learning, and also GAN is a generative adversarial neural networks models. And here, when we are hybrid approach, these are the conditions and advantages used for this hybrid approach: improved accuracy, and the second one is enhanced robustness. The hybrid approach, by leveraging synthetic data, results in improved accuracy and robustness, making the model less prone to the overfitting. And coming to data heterogeneity. Data heterogeneity, it is a hybrid approach effectively addressing the challenge of the data heterogeneity by integrating the information from diverse data sources. And coming to scalability, how the synthetic data generation allows the model to handle large data sets without compromising the performance and ensuring the scalability. And also here another one advantage is the real-time processing. Already we have discussed real-time applications related to hybrid approach. The real-time processing is the hybrid approach can be designed for real-time processing, making it suitable for time-sensitive and IoT applications. And coming to discussing related to hybrid deep learning related to using IoT, there are some case studies and experimental results. The case studies are smart home security. This is the model demonstrates improved accuracy in detecting anomalies and predicting potential security threats in smart homes. Smart homes today's various countries are using the smart home security related to smart homes. And also coming to another case study is industrial predictive maintenance. Like industrial IoT is related to, like already discussed, like quality controlling, predictive maintenance, and supply chain automation or optimization. And these are the model effectively predicts equipment failures in industrial settings, minimizing the downtime and maximizing the efficiency. This is the very important nowadays in the industrial related to IoT or anything. And coming to another real world applications is and also case studies related to traffic management system. Traffic management system is mainly in smart cities. Various occurs like smart cities. The model optimizes traffic flow by accurately predicting aviation patterns and suggesting efficient route planning. These are the case studies and experimental results. And coming to discussion in the future research directions, it is very important related to this hybrid deep learning related to IoT. These are the privacy and security exploring techniques to enhance privacy and security in hybrid deep learning models for IoT applications. And coming to another research directions, we can involve for emerging technologies when we are writing the research proposals, satisfying the real conditions, how it will be connected to real applications, and how it will be helpful for the society, for different communities in different area, or different advantages involved related to that. We have to see the future research directions related. And coming to federated learning, it is investigating to integration of federated learning with the hybrid approach and to address the data privacy concerns. And coming to another future research direction is explainability. And this is the developing methods to make the hybrid model for more explainable, enhancing transparency and trust in its decision. And coming to another concept is the Internet of Things. It is we will discuss about the brief overview, and you can understand the real applications and benefits, components, and how the research is doing current. And already you know that Internet of Things and how the systems and various domains, challenges, limitations, traditional to IoT approaches. Internet of Things refers to the network of physical objects or devices embedded with sensors, software, and network connectivity, and enabling them to collect and exchange the data. These devices are interconnected through the internet, forming a vast ecosystem of smart objects capable of interacting with each other and their environment. Environment is very, very important. When we are discussing like non-traditional like IoT or deep learning or anything, we can't discuss the environment. Also, we have to manage the both the technology and techniques and related to. When we are discussing this IoT, there are the real world examples, key aspects of IoT. And real world examples, think of smart homes. Smart homes are generally when you are using home where applications like refrigerators and thermostats can communicate and adjust automatically, or consider wearable fitness trackers that collect data on your health and send it to your smartphone. This is the linked interconnectivity to smartphone. These are the just few examples of how IoT is changing our lives. And coming to these IoT key aspects, IoT encompasses several key elements including data collection, communication protocols, and data analysis. These elements work together to enable intelligent decision making for automation and improved efficiency in various domains. And when we are discussing IoT or real applications of key concepts of key components of the IoT, there are the general components, key components of IoT is sensors, actuators, gateways, cloud computing. For any applications, any healthcare, agriculture, anything, and also like sensors, how it will work and what is the components and what is the working principle and process. Sensors act as the eyes and ears of the IoT ecosystem and collecting data from the physical environment, and they measure parameters like temperature, pressure, light, and motion, and converting them into electronic signals that can be transmitted over the network. And coming to another components of IoT is the actuators. Actuators are the muscles of the IoT. It is responding to data received from sensors and controlling physical devices or systems. They translate digital signals into the physical actions, adjusting parameters or initiating process based on the received information. These are the components IoT is interlinked to each other. And coming to another components of the IoT is gateways. Gateways act as a bridges between different communication networks, enabling seamless data exchange between IoT devices and the internet. They translate data between different protocols, ensuring smooth communication and data flow across the ecosystem. And coming to another component of IoT is the cloud computing. Cloud computing provides a platform for storing, processing, sorry, and analyzing massive amounts of the data collected by IoT devices. When we are discussing about the components of IoT related to cloud computing, the cloud infrastructure enables scalability and also data security and advanced analytics and capabilities, powering intelligent decision making. These are the general components of IoT. Here, when we are discussing the components of IoT, these are the basic components generally using. These all this states the main keywords for understanding of the basics IoT and also IoT challenges and how it will be potential for a GAN addresses by the IoT challenges and exploring of the various hybrid deep learning models for IoT applications. And it gain insights into the latest research trends and future direction in this field. And coming to this IoT related like smart devices and sensors. You know the all the like the cameras, temperature sensors, GPS devices, health sensors. We can see detailed discussion and detailed definitions and how it will helpful for the connection and interconnectivity. When we are discussing about the cameras, it is the principle and how it will works and how it will be generating like cameras capture visual data, offering insights into traffic patterns, security breaches, and remote monitoring applications. And also, it is cameras used widely used in surveillance also, in traffic management, and even wildlife tracking. Coming to temperature sensors monitor the environment, ensuring optimal conditions in buildings, industrial process, and medical equipment. And the temperature sensors play a critical role in climate controlling safety and efficiency. These are major important. Nowadays, these temperature sensors are used in medical and healthcare applications very well. And coming to GPS devices, these GPS devices provides location data enabling the tracking of effects and fleet management and navigation. They find application in logistics, transportation, and personal navigation. And coming to another one is health sensors. Health sensors monitor vital signs, providing real-time insights into health conditions. And actively levels in medication adherence, they empower individuals to take control of their health and facilitate personalized healthcare. And these are the major things and how this will helpful with current technology is very important. In this, all when we are using, there are the different key techniques like data augmentation or anomaly detection or privacy preserving, data sharing or edge computing or IoT security. These are the general key techniques related to this. And also coming to the connectivity and communication protocols, these are the connections and protocols. There are four. First one is Bluetooth, second one is Wi-Fi, the third one is cellular networks, and fourth one is low power wide area networks. We will discuss clearly about these four, and first we will discuss about Bluetooth and how the connectivity Bluetooth enables short range communication between devices, commonly used for connecting wearables, smart speakers, and other nearby devices. This Bluetooth connectivity having its energy efficient, reliable, and commonly found in consumer devices. These are the Bluetooth connectivity. And coming to another one is Wi-Fi. Here, Wi-Fi provides a more robust and faster connection for devices within a local network and enabling streaming high bandwidth data transferring and home automation applications. It's a wide available in homes and offices used in related to Wi-Fi. And coming to another protocols like community protocols like cellular networks. Cellular networks provides ubiquitous connectivity like connectivity related to networks enabling the devices to communicate even when not in close proximity to a Wi-Fi network. This is the crucial for remote monitoring and asset tracking and applications requiring for long-range communications. And coming to another communication protocol is low power wide area networks. Low power wide area networks is optimizing connectivity for devices that require low power consumption and a long range communication, and how these networks are ideal for sensor networks and how it will be asset for tracking and smart city applications. Already we have discussed smart city like traffic management, vehicle maintenance, and energy optimization. And these are the different connections and community protocols used. And coming to data collection and analysis, how the data will be collected and how it will be analyzed, and what is the differences between collection of the data. And coming to data collection, it is the IoT devices continuously collect the data from their surroundings, generating massive amounts of information. In this data collection, this data provides valuable insights into various aspects of the physical world. And this takes a major role for this data collection, and also these related to the data transmission. The data transmission takes the major role for collection of the data is transmitted to the cloud or a central data, a storage platform using communication protocols. It is used for ensuring secure and reliable data transfer. This enables efficient data management and processing. And these are the data management and data analysis, data collections. These all are used for the analysis. And also here, when we are discussing about this all the data collection, analysis and interconnectivity, here the GAN-based algorithm learning approaches for IoT. And here, when we are discussing the clear security and data analytics, edge computing, these all are interconnected with each other, and it works the clear picture of this analysis. And coming to IoT applications across industries, how the industries These industries of IoT will be based on quality control and predictive maintenance. This takes the major role. And when we are discussing with industrial IoT, how the quality control taken place? Mainly, this industrial IoT, the quality control, GAN can generate synthetic images of defective products to train computer vision models for quality inspection. And coming to this industrial IoT related for the predictive maintenance, it is the analyzing sensor data, and GAN can predict equipment failures and schedule maintenance proactively. These are the interconnectivity for the IoT application across industries. There are smart homes, smart cities, healthcare, manufacturing. These are the 4 applications, and how the IoT takes the major role for real applications, real world. In the smart homes, IoT is transforming the way we live, creating smart homes with connected appliances, security systems, and lighting. And coming to these technologies offer convenience, efficiency, and enhanced safety. And coming to smart cities. And come on to smart cities is related to IoT application industries. IoT enables the smart cities to manage the traffic, optimizing energy consumption, enhance public safety, to improve the citizen services for the people, and how the services will be helpful. When we are discussing about the traffic management related to smart cities, GAN can generate realistic traffic simulation to optimize the traffic flow and reduce congestion. And it is the main condition. And when we are discussing the connected related to smart cities, infrastructure and data-driven decision making create a more efficient and sustainable urban environment. In these smart cities, the maintenance is also very important. Predictive maintenance is very important. Predictive maintenance is by analyzing the sensor data, and GAN can predict equipment failures and schedule maintenance proactively. And coming to another applications related in healthcare, it's taking major role nowadays. This interconnectivity to IoT. IoT is revolutionizing healthcare, enabling remote patient monitoring, personalized medicine, and efficient healthcare delivery, and connected medical devices and wearable sensors, and offer improved care and patient outcomes. And when we are discussing these IoT applications related to healthcare, generally when we are nowadays medical image analysis is very, very important. This takes the major applications for the real time. Medical image analysis and how it connects the GAN, and GAN can generate synthetic medical images to augment data sets and improve the accuracy of diagnostic models. And another one is in this healthcare application, real-time application is personalized medicine. Personalized medicine is also for analyzing the sensor data for GAN. GAN can generate personalized treatment. Treatment of the planning is very, very important for personalized medicine. It takes a major role. And coming to the manufacturing. In this manufacturing also leads today's world. And also here already we are in Industry 5.0. Here when we are discussing manufacturing of IoT is driving Industry 4.0, transforming the manufacturing process through automation, predictive maintenance, and real-time data analysis. This leads to increased efficiency, reduced downtime, and improved product quality. IoT is related different applications. The Tesla also using real-time applications like IoT related to manufacturing. And coming to the when we are discussing this all IoT related applications or real-time applications, and we have to understand the benefits and how the benefits will be implemented on IoT. It is the need to know the benefits we are implementing an IoT approach. When we are implementing an IoT approach, there will be an increased efficiency, cost savings, enhanced decision making, improved customer experience. When we see the detail, we will see increased efficiency. When we are implementing an IoT, what are the benefits? How it will be increased efficiency. IoT automates tasks, optimizes process, and reduce manual labor, and leading to increased efficiency and productivity. This efficiency saves timing, resources, cost in various industries. It may be industrial IoT or manufacturing industry, everything. And coming to cost savings. When we are implementing our IoT benefits, cost savings is IoT technologies like predictive maintenance help identifying the potential issues before they occur. Here, minimizing downtime and reducing the maintenance costs and efficient resource utilization, and also contributes to significant cost saving. And coming to another benefit is enhanced decision making. IoT enables the data-driven decision making, providing valuable insights into operations and customer behavior. These insights guide strategic planning, improve the product development, and enhance customer service. And coming to another benefit is improved customer experience. It is important. IoT techniques enable personalized experience and tailored to individual preferences. This leads to increased customer satisfaction, loyalty, and brand advocacy. Brand is also important, and also the ultimately driving business growth. To improve the business growth, these are the major benefits when we are implementing on IoT. And what are the challenges and considerations, and how it will be helpful, and how the major role taking place. When we are discussing about the challenges, how it will be considered. The challenges of the like the data security, privacy concerns, interoperability, and also infrastructure costs. Coming to data security protects the sensitive data from unauthorized access is paramount. It is a robust security measures are essential to prevent data breaches, ensure the integrity of the IoT systems. When we are discussing this IoT security, also it having the generally the security will takes place adversarial attacks or intrusion detection. When we are discussing the security, adversarial attacks, GAN can be used to generate adversarial example to test the robustness of IoT security systems for identifying the vulnerabilities. And coming to intrusion detection, this is also one security related. By analyzing network traffic patterns, GAN can detect anomalies and potential security breaches. And coming to privacy concerns. Privacy concerns is the IoT devices collect personal data, raising privacy concerns for ethical guidelines and transparent data protection. And practices are crucial for protecting user privacy. And coming to interoperability, and in ensuring seamless communication and data exchange between devices from different manufacturers remains its challenge. And also, here standardization efforts are underway to address interoperability issues. And also coming to other challenges and how we consider infrastructure costs. Implementing IoT requires significant investment in infrastructure, and there are the different components and areas, including sensors, gateways, data storage platforms, and infrastructure costs. Having the cost-effective solutions and innovative funding models are critical for widespread adoption. These all will be taken place the major role. Nowadays, privacy reserving and data sharing is takes the major role. No challenges in also consideration. How the privacy and preserving data sharing is, there will be a protecting sensitive information. The sensitive data, sensitive information, GAN can generate synthetic data that maintains the statistical properties of real-time data while making sensitive details. And coming to another privacy preserving data sharing is enabling collaborative research. These researchers can share synthetic data without compromising privacy, fostering collaboration and innovation. And these are the challenges and considerations nowadays. And coming to how the future of Internet of Things or the IoT, the transformative potential of IoT, and the future IoT holds immense promise with advancements like 4.0 related to artificial intelligence, machine learning, edge computing, driving continuous innovation, and the IoT will continue to reshape industries, transforming how we live, work, interact with the world around us. These are the different future of IoT and how it will potential for IoT. It is very, very important. Nowadays, Industry 5.0 also takes the major role of the human robots, how it will helpful for agriculture, commerce, or healthcare industries, or different manufacturing industries, or industrial IoT, or robotics, industrial IoT, or any automotive or aerospace industries also. And now we will see challenges in the Internet of Things. We have to face the different challenges, and how the challenges take place in IoT is very, very important. The challenges in IoT is when we are discussing this Internet of Things, this Internet of Things is rapidly changing the world, connecting billions of devices and transforming industries, and how the challenges take the growth brings with its unique challenges, particularly in data management. And for the security and scalability. When we are discussing the data management or the data augmentation, having the enhancing data set diversity. Enhancing data diversity is the GAN can generate synthetic data to augment limited training data sets for improving model generation or generalization and reducing overfitting. In this data augmentation, or the data-related challenges having the addressing the data imbalance. When we are discussing the addressing of the data imbalance, it will by creating the additional samples for unrepresented classes, and GAN can help mitigate bias and improve the model performance. And this plays the major role, particularly for this another. These challenges of IoT takes these like critical issues or exploring solutions, strategies of navigating the dynamic landscape. And compare when we are discussing the comparing related to the rise of the IoT and connected to the world. In this ubiquitous connectivity or data explosion, ubiquitous connectivity is the Internet of Things has become an integral part of our lives. These become an integral part of our lives, connecting everything from our homes, cars to our workplaces and cities. This interconnectedness is transforming the way we live, work, and interact with the world around us. And coming to the connection of the world of data explosion, the sheer volume of the data generated by IoT devices is growing exponentially, creating immense opportunities for valuable insights and data-driven decision making. However, managing and analyzing this vast amount of data is a significant challenge. These are the main challenges related to IoT. When we are discussing about the challenges of the IoT, here the quality also important, data quality. How the data quality, the foundation of the data quality of foundation of the having the heterogeneous sources, data accuracy, and data completeness. When we are discussing the detailed discussion on heterogeneous sources, heterogeneous sources are the IoT devices come in a wide range of shapes and sizes, each collecting data in different formats. This diversity makes it challenging to ensure consistency and reliability across all data sources. And coming to another data quality is data accuracy. When we are discussing about the quality, trust is important. There is a relationship between the quality and the trust. The data accuracy, the data collected by IoT devices must be accurate and reliable to make informed decisions. And also in this data accuracy, faulty sensors, network disruptions, or data manipulation can compromise the integrity of the data. In this data quality or the foundation of the trust, having discussion in this data completeness. Data completeness is a missing or incomplete data can lead to inaccurate analysis and decision making. Ensuring data completeness is crucial for deriving meaningful insights from IoT data. These are all related to this discussion related to quality and what are the different foundation of the trusting is very, very important. In this concept, you can understand how the data normalization and how the data normalization unifying the data. In this discussing about the normalization of data unifying the data, here there will be a standardized formats, data integrity and enhanced analysis. And also here standardized formats tells the conditions satisfying the required data for data normalization involves the transforming data from various sources into a consistent format. The standard format will be interconnected with IoT data analytics also. This process ensures that data from different devices can be easily integrated and analyzed. And coming to data integrity, by standardizing data formats and normalizing helps to maintain the data integrity and reducing the errors and inconsistencies that can arise from heterogeneous data sources. There will be interconnectivity with data integrity or IoT data analytics. IoT data analytics having the data augmentation. Data augmentation GAN can generate the synthetic data to augmented limited training data sets. It will helpful for improving the performance of deep learning models. And coming to this IoT data analytics, having the missing data imputation like GAN can be used to fill the missing data points by generating classable values based on the patterns in the available data. In this data analytics feature engineering. In this feature engineering, GAN can be employed to create new features from existing one and enhancing the predictive power of machine. And machine learning models. And coming to enhanced analysis. And how the enhanced analysis and how it will be helpful. And what is the need of enhanced analysis is very, very important. Enhanced analysis is a normalized data. It is easier to analyze, allowing for more efficient and accurate insights from the vast amount of data generated by IoT devices. These all are advantages for the GAN-based IoT deep learning for IoT. When we are discussing enhanced analysis, there will be an interconnectivity with enhanced model performance and also enhanced privacy and security. Enhanced analysis takes the enhanced model performance. In the enhanced model performance, GAN can improve the accuracy and robustness of deep learning models by providing additional training data and mitigating overfitting. And coming to enhanced privacy and security, GAN can be used to protect sensitive data and enhance the security of IoT systems. And coming to the sensor calibration, ensuring data accuracy. Sensor calibration and also related ensuring the data accuracy. It is the regular calibration. Regular calibration and how it will involve and what is the necessity involving and how it will work and how it connects is very, very important. In this regular calibration, sensors can require periodic calibration to maintain accuracy and consistency over time. The regular calibration involves comparing sensor reading to know the standards and adjusting them as needed. And coming to environmental factors such as temperature, humidity, pressure can affect sensor performance. Calibration helps account for these variations and ensures accurate data collection. And coming to this calibration, ensuring data accuracy is a data validation. Data validation is calibrated sensors to produce more accurate data, leading to better insights and improved decision making. This ensures the data used for analysis is reliable and trustworthy. And these are the major terms for the ensuring the data accuracy. And how the security concerns with the correction world or correcting world. The security concerns in connected world having the data breaches can expose sensitive information and leading to financial losses, reputational damage, and security risks. And coming to the second one is security concerns in the international world. It is a malicious actors can exploit vulnerabilities in the IoT devices to gain unauthorized access to data, disrupt operations, or launch attacks. And coming to third one, that is the distributed nature of IoT systems makes it difficult to secure all devices and data points and requiring comprehensive security measures. These are the security concerns when we are connecting IoT. And coming to the authentication and authorization and how it will access control and what are the main key conditions satisfying these authentications are very important. In this authentication and authorization to access the control, it is the secure logins. Like we have to keep the strong passwords, multi-factor authentication, and biometrics are essential for preventing unauthorized access to IoT devices and data. You can observe the screen and how the authentication authorization access controlling. And coming to role-based access, it is the different users should have different levels of access to IoT devices and data based on their roles and responsibilities. And how the access and how it will be controlled. Access control lists. Access control list is which users or devices are allowed to access specific resources and ensuring the data security and confidentiality is very, very important. Data confidentiality is very, very important when we are sharing related to privacy or security related activities and how it will be accessed and how it will be controlled is very important. And coming to encryption and data protection. Data protection is also very, very important when we are explaining about the quality, performance, security, adaptability. Data protection also takes the major role in this main concept. When we are discussing about this data protection, the data protection the encryption having the data encryption converts the sensitive information into an unreadable format, making it difficult for unauthorized individuals to access. And coming to secure communication. So to secure the communication protocols such as transport layer security and ensure that data transmitted between devices and the cloud is protected. And coming to the data storage security, the data stored in the cloud or on IoT devices should be encrypted to prevent unauthorized access even in case of breach. These are the three concepts major takes the key role for encryption and data protection. Encryption, data encryption, security communication, and also data storage security. And coming to the scalability and how it will useful for the managing growth and what are the key concepts involved in this managing growth is it. In this scalability of managing growth for the device proliferation, it is the rapid growth of IoT devices. It creates a significant challenge in managing and processing the increasing volume of the data. And coming to the scalability related to managing growth and having the data storage capacity. Data storage capacity is useful for storing and retrieving vast amounts of IoT. IoT data requires efficient data management systems and a large storage capacity. And when we are discussing about the managing growth of the scalability, the data storage capacity and also the data processing power is also very important. The data processing power is analyzing and extracting the insights from massive data sets. It requires the more powerful computing resources to handle the increased workload. Setting the main important and major conditions satisfying to manage the growth. And coming to the overcoming IoT challenges and solutions and strategies. And how it will helpful and what is the need and where it will be applicable is very important, and how the approaches will be taken place. To overcoming IoT challenges, solutions and strategies, there are edge computing, fog architecture, data analytic tools, cybersecurity measures. When we are discussing the edge computing, it brings the data processing closer to the sources, and also the reducing the latency and bandwidth requirements. And coming to fog architecture extends the cloud to the edge, providing distributed computing resources and data management. And coming to another IoT challenge to get the solutions and strategies, data analytics tools. Data analytics tools, having the advanced data analytics tools, enable efficient data processing, visualizing, the visualization and insights from large IoT data sets. And coming to another one is cybersecurity measures. Cybersecurity measures for implementing robust cybersecurity measure including firewalls, intrusion detection systems, and data encryption and essential. Already we have discussed the intrusion detection. Intrusion detection is by analyzing the network traffic patterns or GAN can detect anomalies and potential security breaches. And when we are discussing the data encryption also, we have seen the data encryption is also essential for overcoming the challenges to get the final solutions and strategies. And next we will see the concept and what is the role of deep learning in IoT. It's the applications of deep learning within vast ecosystems of connected devices. And what is the role of, we have seen the role of the IoT and how the approaches and hybrid approaches in IoT. And now we will see the role of deep learning in IoT. Here, when we are discussing about the role of deep learning in IoT, role of deep learning in IoT is to interconnectivity to control the overcoming the IoT challenges, solutions, and strategies. These are the edge computing fog architecture or the when we are discussing the previous we have seen the overcoming IoT challenges for the solution strategies also. Now this is the role of deep learning IoT. These are the interconnections First, we will see how the role deep learning and IoT and what is the intersection of IoT and opportunities and challenges related to the deep learning in IoT. Opportunities, the IoT presents a vast opportunities for innovation. Imagine a world where your appliances communicate, predict your needs, and for optimizing the energy consumption. These benefits are transforming industries, creating new products, and enhancing our lives. And coming to challenges. Challenges, IoT comes with challenges related and relationship with data security, privacy, and managing vast amounts of data are critical concerns. Addressing these challenges is essential for responsible and sustainable IoT development. And coming to the fundamentals of deep learning, there will be a different fundamentals of deep learning. Fundamentals of deep learning having like neural networks, learning algorithms, training and evaluation. Fundamentals of deep learning having neural network, deep learning employs artificial neural networks inspired by the structure of the human brain. These networks learn complex patterns from data and make predictions. In these fundamentals of deep learning, learning algorithms is also very important. Learning algorithms, deep learning algorithms like convolutional neural networks or recurrent neural networks processing different types of data, enabling sophisticated analysis. When we are discussing the previous slides or videos works in hybrid deep learning. In hybrid deep learning, this approach combines the multiple deep learning techniques such as convolutional neural networks or recurrent neural networks and GAN to create powerful models for complex tasks. And coming to the another one is training and evaluation. Training and evaluation takes the major role. Training deep learning models requires large data sets and computational power. Once trained, models are rigorously evaluated to measure their accuracy and performance. These are the three fundamentals of deep learning. And coming to and how this deep learning, applying the deep learning in IoT scenarios. How the deep learning applying for IoT scenarios. In this, when we are discussing these deep learning, hybrid deep learning models for IoT also, it is a combination of GAN with other deep learning techniques, CNN, RNN, and it benefits for the hybrid models for IoT applications. In this scenario, there will be applications already, you know that the three takes a major role nowadays for real-time applications: smart homes, smart cities, and healthcare. Smart homes deep learning empowers intelligent home devices to understand user preferences, personalizes settings, and automate tasks. This creates a more comfortable and efficient living experience. And coming to the another application is smart cities. Deep learning analyzes data from traffic sensors, weather stations, and other sources to optimize city operations and also to improve the traffic flow and to enhance public safety. Already you know that smart cities like traffic management, predictive maintenance, and energy optimization. And coming to healthcare. Healthcare is commonly you know that the deep learning helps with the monitor patient health, analyzing the medical images, and predicting the potential health issues, improving patient care and disease management. In this healthcare medical image analysis, drug discovery and personalized medicine takes a major role and major applications for the healthcare. And coming to the computer vision in IoT, how the computer vision in IoT and how the object detection and classification is very, very important. In this, there are computer vision IoT having the object detection classification where we use, where will applicable, what are the different logic involved in this self-driving vehicles. In these self-driving vehicles, smart security systems and industrial automation. And when we are discussing about the self-driving vehicles and how the deep learning will be helpful and how it will be useful, deep learning powers autonomous vehicles to perceive their surroundings and detect the objects and make informed decisions in real time and paving the way for safer and more efficient transportation. And coming to smart security systems. In the smart security systems, deep learning enhances the security cameras to identify intruders, detect suspicious activities, and to provide real-time applications is very, very important. And in the smart systems, in the smart security system, the deep learning enhances the security cameras to identify intruders and to detect suspicious activities and provide real-time alerts and making homes and business more secure. And coming to industrial automation, deep learning enables robots to recognize the interact with objects in the workplace, improving efficiency and safety in manufacturing and other industries. These are the different computer vision and IoT and object detection, and these are the three classifications involved through IoT. And coming to the natural language processing for IoT devices in the deep learning concept. In this natural language processing for IoT devices, there will be controlling of voice control and also coming to text analysis, personalized recommendations. And coming to voice control. Voice control is a deep learning enables IoT devices to understand spoken commands, allowing users to interact with their devices hands-free. This enhances accessibility and convenience. And coming to text analysis, deep learning process text data from social media, sensors, and other sources, providing insights into user sentiment, behavior, and trends. And coming to the personalized recommendations, is deep learning analyzes user preferences and past interactions to provide personalized recommendations for products, services, and information. And coming to predictive maintenance with deep learning. In this predictive maintenance with deep learning, having the data collection, pattern recognition, and predictive alerts. First, we will see how the maintenance and prediction taking place with respect to data collection with deep learning. Data collection or predictive maintenance with deep learning is very, very important. In this data collection, sensors gather real-time data on machine performance, including vibration, temperature, and pressure readings. This data is essential for predictive maintenance. And coming to pattern recognition, the deep learning models analyze historical data to identify patterns and anomalies that indicate potential equipment failure. This early detection is crucial for preventing downtime. The maintenance predictive maintenance also takes the major role, very important with the deep learning. And coming to the predictive alerts, the models provides alerts and recommendations for preventive maintenance, allowing engineers to schedule maintenance before equipment failure occurs. And coming to the edge computing and deep learning in IoT, it is useful for reduced latency and enhanced privacy and to improve efficiency. And when we are discussing and we know the common key word like reduced latency. Reduced latency is the edge computing enables real-time decision making by processing data locally and reducing the reliance on cloud servers and minimizing delays. And this is the essential for applications like autonomous vehicles. In this edge computing and deep learning in IoT, enhanced privacy is also very important. Enhanced privacy is key. Processing the data at the edge reduces the need to transmit sensitive information to the cloud, enhancing data privacy and security. And this is the critical for healthcare and other applications for enhancing the privacy. And coming to the improved efficiency, it is the edge computing distributes computational tasks across the multiple devices nowadays and reducing the load on central servers and improving overall system efficiency. These are the key ways and edge computing and deep learning in IoT. And how the privacy or securing in related to deep learning through IoT. For securing and privacy for preserving deep learning for IoT, there will be a data encryption, federated learning, differential privacy. First, we will see the data encryption. Data encryption is to protect the sensitive data is crucial in the IoT. Encryption techniques safeguard the data during transmission and storage, ensuring privacy and security. And coming to federated learning. Federated learning allows training models on decentralized data without sharing raw data. This approach improves data privacy and enables collaborative learning. And coming to differential privacy. Differential privacy adds noise to data before sharing it. Differential privacy is useful for protecting individual user information while still enabling valuable insights from collective data. These are the three techniques used for securing and privacy and to get the preserving deep learning for IoT. And we will see how the future of deep learning in IoT and what are the major conditions for this future takes place and what is the importance and how the future of deep learning in IoT is very important. In this future of learning in IoT discussions, you have to understand the integration of deep learning with the IoT is revolutionizing industries and shaping our future. This technology promises exciting the possibilities for enhancing efficiency, improving safety, and personalizing our experiences as the IoT continues. As the IoT continues to grow, deep learning will play a crucial role in unlocking its full potential. And also, this future of deep learning IoT is taking creating the new world of connected and intelligent devices and that serves our needs and enhance our lives. These are the major conditions and major terms used for the future of deep learning in IoT. And coming to generative adversarial networks, a primer, it is the generative adversarial primer. We have to understand how the key component training process, diverse application challenges, and what are the architectures. We will discuss promising of the directions in GAN research in promising directions. And already we know that we have seen different applications, different conditions, IoTs related like deep learning. And we have seen this is the clear picture and clear concept used for the introduction to GNS. Already we know that the GAN is a generative adversarial network, a class of artificial neural networks that learn to generate new data similar to the training data. This GAN takes the major role related to hybrid or deep learning or IoT to IoT. These training data, they consist of two competing neural networks, a generative model and discriminative model. And in this GAN, having the core principle, generative model attempts to create realistic synthetic data, while the discriminative model evaluates the generated data and distinguishes it from real data. The two models play a zero-sum game and game constantly improving their performance by challenging each other. And what are the key concepts in GAN? Already you know that the generative model discriminated. Generative model is also known as generator learns to create new data samples from a random noise input. It aims to deceive the discriminative model by generating realistic data. And coming to discriminative model, the discriminative model also knows as the discriminator is trained to distinguish between real data and generated data. It acts as judge, evaluating the quality of the generated data and providing feedback to the generator. This descriptive model takes the components, these are the two components of GAN. And coming to generative model and adversarial model, generative model takes a random noise vector as input transformed into a data sample. And generative model goal is to create the data that resembles the real training data and fooling the discriminative model. And coming to adversarial model or discriminator is trained to classify the real data as the real and generated data is fake. Real data as real and generated data is fake. It acts as a judge, providing the feedback to the generative model to improve its generation quality. This is the difference between generative model and adversarial model in data sets. And coming to the training process of GNS, and here GNS having been initializing when we are starting with the random initialization of the generator and discriminator model networks. And second step is to train the discriminator. To train the discriminator learns to distinguish real data from generated data by training on both real and generated samples. And coming to train the generator learns to produce more realistic data by trying to fool the discriminator. It updates its parameter to generate data that the discriminator classifies as real. And coming to iterate, the training process repeats steps 2 and 3 iteratively. Generator and discriminator improve their abilities over time, leading to more realistic generated data. These are the training process of the GANs, generative adversarial network. And coming to these applications of GANs, these are the future and current applications and how you can observe the different images, how the images will be generated with the help of GANs. Applications of GANs, it is the having the image generation, image enhancement, data augmentation, and style transfer. These are the real different examples for the applications of GANs. Whole final generation of the pictures and figures and how it will be converted. When we are discussing about the image generation, how the image generation and how it involves and how it works. Image generation is creating realistic images of faces, landscapes, and objects, pushing the boundaries of creative expression and providing valuable tools for artists and designers. And coming to image enhancement. Image enhancement do the improving the quality of images by removing the noise, enhancing resolution, and distorting missing parts, enhancing the visual quality of photographs and videos. And this is the image enhancement and different applications used for the GMS. And here, when we are discussing about the image enhancement, here when we are improving the quality or removing the noises or enhancing resolutions, and these all are the useful things, restarting the missing parts or the enhancing the visual quality of the photographs and videos. This takes the major role and major part for the image enhancement. And coming to the data augmentation, how the data augmentation takes place in this GAN and how there is generative adversarial networks working or mechanism and how the applications of generative adversarial networks in image generation or data augmentation and anomaly detection. When we are discussing the data augmentation is the expanding existing data sets by generating synthetic data and samples similar to the real data and allowing for more robust model training and reducing overfitting. And coming to the another application is style transfer. You can observe this is the different style and how it will transforming and how it will helpful. This is the style GNS. Style transfer, transferring the artistic style. Artistic style of one image to another. It is style transferring to creating the unique, captivating works of art and facilitating creative exploration. These are the general applications for the GANS. You can understand the clear applications, you can know the applications, you can observe these figures and how the image generation taken place, how the image enhancement taken place, and how backup of the data augmentation taken place, and how a different style transferring in GANS is very, very important. These are the major roles and major key terms for the applications of GANS. We have seen the applications, now we will see the challenges and limitations or disadvantages of GANS. And what are the different challenges and what are the disadvantages of GANS, we will see clear. In this training instability, GAN can be notoriously difficult to train, often exhibiting instability and unpredictable behavior. This training instability having this makes achieving consistent and high quality results challenging. And these are the challenges. And coming to another one is modal collapse. Modal collapse, GAN may exhibit modal collapse where the generator produces only a limited variety of generated samples, failing to capture the full of diversity to the real data. This is the modal collapse or mode collapse. These are the disadvantages for the GANs. And coming to evaluation difficulty, evaluating the performance of GAN can be tricky due to subjective nature of evaluating the quality of generated data. There is no single universally agreed upon metric for evaluating GANs. These are the challenges and limitations of GANs. And coming to architectural variations of GANs. When we go the concept of architecture, a different concept, and how the variations involved in GANs. In these architectural variations of GANs, first one is deep convolutional GANs. Second one is Weserstein GANs. And coming to big GANs. First, we will see the deep convolutional GANs and what is the need of doing deep convolutional GANs for architectural variations and architecture concept. In this concept, deep convolutional GANs utilize the convolutional layers in both the generator and discriminator, and enabling them to learn more complex patterns and generate high resolution images. And coming to Weserstein GANs, this is the different one. Weserstein GANs address the instability problem by using a different objective function that encourages the generator to learn a smoother distribution of the data. And coming to big GANs, how the big GANs will be helpful for the architectural variations of GAN is very important. In these big GANs are highly scalable GAN and that can generate high quality images with impressive resolution and diversity. They are trained on massive data sets using large scale computing resources. These are the three different architectural variations of GANs. And coming to the evaluation of metrics for GANs. Evaluation of metrics for GANs. Evaluation of the metrics for GANs having the inception core, first one. Number two, featured inception distance. Third one is kernel inception distance. First, we will see when we are evaluation metrics for GANs inception score. Inception score mainly works for the measure to measure the diversity and quality of generated images. Higher score indicates more realistic and diverse generated samples. And coming to featured inception distance, featured inception distance, it calculates the distance between the distributions of real and generated data. It a lower effort indicates a better alignment between the generated and real data distributions. And coming to third one is evaluation metrics for GANs having the kernel inception distance. It is new one. Kernel inception distance KID measures the similarity between the feature representation of real and generated images. Already we have seen the clear images, clear picture, clear artists, and clear style. And here the lower kernel inception distance indicates a closer match between the feature spaces of real and generated data. These are the three metrics evaluation usual for the GANs. And coming to these all recent advancements in GAN research and future directions. This is very, very important. Any concept, any knowledge, gaining also, we have to concentrate on future directions for. Future technology takes a major role in GAN research. In these recent advancements, GAN research have focused on improving stability. For improving the stability and to addressing the board collapse and enhancing the image quality. And here the future of the GNS is bright with promising directions, including exploring new architectures and developing more robust evaluation metrics and expanding their applications to other domains such as text, audio, and video generation. These are the recent advancements in GAN research and future directions, very useful. And it will helpful for research proposals also to write the good proposal to get the funds. Sanctioning also very useful. And coming to the concept is hybrid deep learning. Hybrid deep learning also, it is the combining the best of both worlds. These are the different concepts used in GAN based technologies. In this hybrid deep learning, combining of the best of both worlds is very important. In this, we have to understand hybrid deep learning, combining the best of both. These are the different steps of traditional deep learning with the efficiency, adaptability of shallow learning techniques, and also to exciting the world of hybrid models, their applications, and the future of artificial intelligence. Coming to hybrid approaches, introduction to the rise of the hybrid approaches, you can see the bridging the gap and the synergy of the techniques. Synergy of the techniques. How the bridging the gap? Here there will be how the gap fulfill and bridging the hybrid. The deep learning emerges as a response to the limitations of traditional deep learning and shallow learning methods. It bridges the gap between these approaches by combining their strengths, unlocking new capabilities, and enhancing AI performance. And coming to the rise of the hybrid approaches, here the different synergy of the techniques. Here, when we are discussing about the synergy of the techniques, here we have to understand how the hybrid approaches are useful for different techniques. Hybrid approaches are useful for the synergy of techniques like hybrid deep learning leverages the power of deep neural networks to load complex patterns from vast data sets while incorporating the efficiency and interpretability of shallow learning models for specific tasks and data types. And coming to traditional deep learning trends and limitations. We have the important traditional deep learning is very important. You can observe the complex gradients and different problems, and we have to improve the strengths and limitations. Here, when we are discussing the traditional deep learning strengths and limitations, first we will see strengths. What are the strengths of this deep learning, traditional deep learning to hybrid approaches? The strengths are useful for the high accuracy, ability to learn complex patterns, and adaptability to diverse data. And coming to disadvantages and limitations, useful for the high computational cost, data hunger, vulnerability to adversarial attacks, and a lack of interpretability. And coming to shallow learning techniques, the complementary approach. Shallow learning technique having the depends upon the decision trees, support vector machines, and linear regression. First, we will see the decision trees. Decision trees, they excel in interpretability, providing clear insights into decision-making process. And coming to support vector machines, they handle high-dimensional data efficiently and offer robust generalization capabilities. And coming to linear regression, Linear regression, they provide a simple and interpretable model for linear relationships in data, making them suitable for prediction tasks. And coming to hybrid models leveraging the synergy. Hybrid models are hybrid approaches for leveraging synergy. It improves the accuracy and also it reduces the computational cost and it enhances the data efficiency. How the improved accuracy will be taken place? Improved accuracy taken place for the combining the strengths of the both approaches leads to enhanced predictive accuracy and improved performance on challenging tasks. And also in the hybrid model for leveraging the synergy, and also here to reduce the computational cost is also very important. Here, when we are reducing the computational cost, leveraging shallow learning techniques for specific tasks reduces the computational burden of deep learning models and making them more efficient. And also enhance data efficiency. With hybrid models can better handle limited data scenarios. It also useful for the employing the slow learning methods for initial processing and feature extraction. And when we are discussing about the hybrid approach and what are the designing of the hybrid approach or the designing of the hybrid architectures is very, very important. There will be, you can observe the figure, the deep learning and the neural networks and how the shallow networks and what are the different conditions satisfying the architecture. When we are designing the hybrid architectures, first two steps we have to understand the deep feature extraction for retrieving the deep learning or deep neural network to extracting high level features from data. And coming to second step is to show or shallow the learning integration for incorporating shallow learning models for specific tasks such as classification or regression. And coming to third step is end-to-end optimization for training entire hybrid architecture to optimize the combined performance of deep and shallow components. And coming to hybrid approaches or hybrid learning algorithms optimization convergence. In this concept, we have to understand the gradient descent, valorization techniques, and ensemble learning. First of all, we know what is gradient descent. Gradient descent is for the adapting gradient descent method to handle the unique structure and the complexities of hybrid architectures. And coming to regularization techniques, it is used for the employing regularization techniques to prevent overfitting and improve the generalization in hybrid models. And coming to ensemble or the learning useful, this is the concept combining the multiple hybrid models to further enhance performance and robustness. And coming to real world applications of hybrid deep learning. You can observe the figure and how hybrid deep learning and what are the different medical images and how it will be extracted and how the image recognition taking place. And these are the real world applications of hybrid deep learning. Real world of the hybrid applications of hybrid deep learning is the real world application of hybrid deep learning is for the image recognition. Image recognition works and how it will transfer. Image recognition works for the hybrid models excel in image classification and object detection, achieving the high accuracy while maintaining efficiency. And coming to the real world applications of hybrid deep learning, second one shows the clear picture of the natural language processing. Natural language processing is useful for the hybrid architectures to enhance the sentiment analysis. For the text summarization and machine translation by leveraging the strengths of both deep and shallow learning. And coming to the medical diagnostics, hybrid models contribute to disease diagnosis and treatment planning, and by combining deep learning for image analysis and shallow learning for decision support. These are the real world applications of hybrid deep learning. These are the three major. This is the example. You can observe the figure: image recognition, natural language processing, medical diagnostics. These are the three examples and real world applications for healthcare industries. Therefore, the hybrid deep learning. And coming to the challenges and considerations in hybrid deep learning. First of all, the challenges will be depend upon depending upon the challenges, we can consider model complexity, data requirements, and interpretability. Model complexity is the designing and optimizing hybrid architectures can be complex, requiring careful consideration of the interplay between deep and shallow components. And coming to the data requirements. Sorry. Data requirements, hybrid models may require diverse data sets for optimal performance. If data requirements will be helpful for posing challenges in data collection and preparation. And coming to interpretability will be very useful for the maintaining interpretability in hybrid models is crucial for understanding their decision-making process and building trust in their predictor. Prediction is very, very important. And coming to future trends and research directions and the power of hybrid deep learning. There are three major useful future trends and research directions and the power of hybrid deep learning. First one is federated learning. Federated learning is useful for integrating federated learning techniques to enable distributed training of hybrid models on privacy preserving data. And second future trends for the research directions to know the explainable artificial intelligence. Explainable artificial intelligence is useful for developing methods for explaining the decision of hybrid models to enhance transparency and build trust. And coming to another future trends and research is AutoML, auto machine learning. Exploring automated machine learning techniques to simplify the design and optimization of hybrid deep learning models. These are the three future research directions to the useful to do the research, current emerging technologies, and with the help of the what we have discussed in the previous different concepts and different real-time applications. These are all very useful for the current trends and current conditions satisfied. Thank you for giving this opportunity. If any doubts and any you can ask me. Hello, madam. Hello. And we will continue next class. Today, madam completed, madam. Madam? Tomorrow, no, madam. Tomorrow 10 to 12, madam. Yes, madam. Yes, madam. We will see tomorrow the continuation and different concepts and different conditions and how it will be useful for the current research. If any doubts, you can clarify your doubts.
Sir. Dear professors, any doubts? Or shall we wind up the class? So there's a question in chat box, sir.
How do we improve the quality or resolution of images generating using GNA? Do we need to retrain the network? No need, madam. With the help of the network, we have seen the CNN and RNN. With the help of this learning architecture and different types, we can generate the clear images. We have seen the applications also. With the help of the learning architectures, we can clear the with the help of CNN and RNA. Use some idea to implement GAN for medical image analysis. Here, when we are implementing the GAN medical images or medical, with the help of the augment data sets and to improve the accuracy in diagnostic model. And these are the useful terms used in this healthcare related. And coming to the another question is, does the hybrid model have more time complexity because we are training shallow and deep models? Yes, madam. It will be the main complexity takes place the major role, and also here when we are discussing the deep models or the different techniques used in this very important. The model compression having the GAN can use it to compress the deep learning models, and here deep learning models to reducing their size and also and computational requirements for deployment are edge devices. This shows the model compression and complexity. Thank you, madam. Thank you, Arindam.
Thank you, sir. Thank you so much, sir, for your wonderful session, sir. So feedback link has been posted in chat box, and tomorrow's session will be by 10 a.m. to 12 p.m. The sir will be same, sir will be continuing. So thank you, sir. It was a very grateful session today, sir. So shall we wind up the class? Okay, thank you all for joining the session. Thank you all.